Let us start a new topic, absolute value function. Absolute value function. Another name for it is modulus, right? And how we denote it is by these two bars. Okay, so absolute value of a number, for example, x is denoted like this, mod of x. So this is known as mod x. Mod is just the short form for modulus. Okay, so how it is defined is that mod of x is equal to x 0 or negative x when x is greater than 0, 0 when x is equal to 0, negative x when x itself is negative, right? For example, to learn it in simple language, if I put negative 3 inside it, it will give me 3. If I, let us say, put 3 inside it, it will give me 3 back. If I put 0, it will give me 0. So it doesn't alter the magnitude, it just changes the sign to positive. So the results, if I see here on the right hand side, are all non-negative results, non-negative, right? So if in brief I can say mod of x is always greater than or equal to 0. Okay, if you look at the number line, if it is 0, and if I go to the right hand side, it will give me 1, 2, 3, and all these positive numbers. There are numbers between 0 and 1 also, 1 and 2. So all the positive numbers are there on the right hand side of 0, and if I go to the negative side, I'll have all these negative numbers. If I take mod of these numbers, for example, if I take mod of negative 3, it will be 3, mod of negative 2 will be 2, mod of 2 will be 2, mod of 3 will be 3. So when I'm moving away from 0, what happens is magnitude of the numbers increases on the right hand side, also on the left hand side. The magnitude increases, so mod value will increase when we go away from 0. Okay, that means even if I put negative 4 here, it will give me 4. If I put negative 5, it will give me 5. So it will keep on increasing. Okay, so let us understand it geometrically. For example, if I say mod of x is equal to 2, let us say. Now let us draw the number line once again. 1, 2, 3, and so on. Negative 1, negative 2, negative 3, and so on the left hand side. So when I am saying mod of x is equal to 2, so what I am saying here is that mod of a real number, okay, I am looking for a real number, the absolute value of which is 2. Okay, so if you can you tell me what is the magnitude of this number here, negative 2, or the absolute value of negative 2 is 2. Okay, and what is the absolute value of this number here? It is also 2. So what I mean here is that the distance from 0 of this number is 2 units, and distance from 0 of this number here is also 2 units. Okay, so when I'm writing mod of x, what I mean is I can write it in another way like this: x minus 0 is equal to 2. So how I read it is that I am looking for a real number x, the distance of which from 0 is 2. Okay, so the distance of this number here, 2, and minus 2 from 0 is same, that is 2 units. So the solution of this will be x is equal to negative 2 or 2, right? So these are the values of x to satisfy this equation here. All right, and when I say, let us say, let me write mod of x minus 1 equals 2. Okay, now what I am looking for is I am looking for a real number x, the distance of which from 1 is 2. look at it geometrically. If it is 1, 2, 3, 4, -1, -2, and so on, I am looking for a real number x, the distance of which from 1. So this is the number 1. Okay. Now from this number 1, I am looking for a real number x which is at a distance of 2 units. So if I go towards right, okay, up to a distance of 2 units, I will reach at this number 3. And if I go towards left 2 units, I'll reach at this number. So x can be -1 or 3. Okay, because -1 and 3 are two such numbers which are at 2 units distance from this number 1 here. Okay, so the solution to this equation is x equals -1, comma 3. Okay, let me take some more examples, then it will be clear. If I, let us say, write it like this: x plus 2 mod is equal to, and let us write 3. Okay, so another way of thinking about it is I can write it like this: x minus of -2 mod equals 3. So now I am looking for a number x which is at a distance of 3 units from -2. Okay, so if it is 0, 1, 2, and so on, -1, -2, -3, -4, and so on. Okay, let me write one more number here. Now this is a number -2. So I am looking for a real number which is at a distance of 3 units from -2. So let me go towards right. 1, 2, 3 units. 3 units to the right. So I will reach here. And 3 units to the left. 1, 2, and 3. I will reach at -5. Okay. So there are two numbers, -5 and 1, that are exactly 3 units away from -2. So the solution to this equation will be x is equal to -5 or 1. This is the solution. You can verify this solution just by putting -5 in place of x. So if you put -5 in place of x, this will become mod of -3, which is nothing but 3. So yes, this answer is verified. And if you put 1, it will give you 1 plus 2, 3. So mod of 3 is again 3, right? So this is verified also. All right. Now if I say, now let me clear this page. If I say mod of x is equal to 2, it will mean x is equal to -2 or 2, right? We saw it on the number line: 0, 1, 2, 3, and so on, -1, -2, and so on the left hand side. So that I am looking for a real number x which is at a distance of 2 units from 0. That is, this is the number 0 and this is the distance 2 units. So I am looking for the numbers which are at 2 units from 0, and these numbers are -2 and 2. Now if I ask you what will be mod x less than 2, right? How do you interpret it geometrically? You can write it like this: I am looking for a number x which is at a distance of less than 2 from 0. Okay, so if I look at this 0, and when I go to the right hand side up to 2 units, I reach at this number 2, and when I go 2 units to the left hand side, I'll reach at -2. Now I am looking for all the real numbers x that are at a distance of less than 2. So if I look at this number here, this distance is 2 units, so this distance is lesser than 2, right? For this number, this number, this number. So any number that lies between -2 and 2, all these numbers will have a distance from 0 that is lesser than 2. Okay, you can verify. This number has got a distance of 1 unit. this number on the in the mid of 1 and -1 and -2, let us say this will be -1.5. So what is the distance of this number from 0? It will be 1.5, which is again less than 2, right? So all the numbers that lie between -2 and 2 will be at a distance lesser than 2 units from 0. So the solution to this equation here is, we can write it like this: x belongs to this open bracket here, -2, 2. That means x lies somewhere between these two numbers, -2 and 2. But it cannot be 2 or -2, right? Because when it is 2 or -2, then mod of x will be equal to 2 and not lesser than 2. In the similar fashion, we can explain mod x greater than 2, right? So again, let me draw this number line: 0, 1, 2, and so on, -1, -2, and so on. So when I say mod x is greater than 2, what I am asking for is, I am asking for some real numbers which are at a distance of greater than 2 units from 0. So any number that lies beyond this 2 or before this -2 will be at a distance of more than 2 units from 0. So if I have to write the solution of this equation, that is this inequation, mod x is greater than 2, then the numbers lying between -∞ to -2 or 2 to infinity, okay, I can go from this 2 to anywhere towards the right hand side. All these numbers that lie on the right side of this 2 will have distance more than 2 from 0, okay. And in the similar fashion, I can say about these numbers. So any number before -2 up to -infinity, or any number after 2 up to positive infinity, all these numbers will be a solution of this inequation, okay. So let me take one more example just to make it very clear to you. Let us take, give me a moment. Let us take mod of x plus 1 equals 5. Okay, so what I'm trying to say here is, I am looking for a real number x which is at a distance of 5 units from this number -1. Okay, so if, let us say, I draw this number line here, 0, 1, 2, 3, 4, 5, 6, and so on the negative side, -1, -2, -3, -4, -5, -6. Okay, so now I am looking for this number -1, and I want to find all the real numbers x that are at a distance of 5 units from this number. So when I go towards right till 5 units, I reach here, right, at this number 4, because 1, 2, 3, 4, 5 units. Okay, so I'll get this 4 here. When I go towards left of this number -1 and go to 5 units on the left, 1, 2, 3, 4, and 5, so I'll reach at -6. So -6 and 4 are two such numbers, okay, that are at a distance of 5 units from -1. So the solution for this is x is equal to -6, 4. But now if I change it into an inequation, let us say x plus 1 is less than 5. Now what it will mean is, I'm looking for a number x that is at a distance of less than 5 units from -1. So that means that number should lie somewhere here, anywhere between -6 and 4. Okay, for example, if let us say I take this number, this is -3. So what is the distance from -1? It is 2 units. Okay, and we are looking for the distance of less than 5 units. So 2 units is obviously lesser than 5 units. Hence the solution to this equation will be any number, x can be any number that lies between -6 and 4. Okay. Also for greater than 5, let us say I write this equation like this. In equation like this, mod of x plus 1 is greater than 5. So any number beyond this 4 will have a distance from -1 greater than 5. So for example, 5 here is at a distance of 6 units from this place. Okay, so any number beyond 5, any number beyond 4 or before -6 will satisfy this inequation. That means x will be lesser than -6 or x will be greater than 4. Another way to write it is x can be from -infinity to -6 or 4 to infinity. Okay, so this is how we can look at these questions geometrically. So we can solve a lot more questions using geometry. Okay, let me cover these questions in the next lecture because this will become very lengthy then.